So, in a recent stream from MightyMeat, he was talking all about the Big Bang Theory, and Valhalla posed a really interesting question, a hypothetical. He asked, what if two objects were passing each other at the speed of light? Meow. And then they go past each other and they're going away from each other. And at that point, the speed differential between them would be twice the speed of light because they're going in opposite directions. Would they even be able to see each other? Because of the light is only going at the speed of light, it wouldn't be able to catch up to the object going away at twice the speed of light. And I just thought it was a really interesting question. And so, if you'll indulge me, I'd like to give my take on what I think would happen in this situation. So, in order to give my answer, I first need to explain something. So, the way I see it, if you look here, you've got, say, an eyeball, and next to it is a tin of paint. And I'm going to use this to represent something to do with light and my opinions on how this would work. So if I was to lift this paint pot up, and let's say it had a reasonable size hole in the bottom, the paint would start to come out. As you can see there, it would start to drop downwards onto the floor. And if I further lift that up fairly quickly in a fluid motion, there would be a constant stream of paint coming down towards the floor. And so imagine, if you will, that this is representing light. So if an object is moving away from me, the light coming back towards me is doing this kind of a thing. Now, generally speaking, most objects are traveling much, much slower than the speed of light. And so as such, the object is visible to us, even though we're technically seeing a representation of the past, because by the time the light gets to our eye, the object has moved, if only ever so very slightly, such a small scale. We are effectively, when we see an object, only ever seeing a past reflection of where it was at that time, because it takes a split second for the light to get from the object to our eye. Now, I find that concept quite interesting in itself, that we never really truly see something at the exact same time that it's there. We're always seeing a kind of a ghost shadow of the past, of where the object used to be. But that delay in the light getting to our eyes from the object is so minimal, usually speaking, that it's practically makes no difference. The object to us is effectively just where it is, even though in reality it may have slightly moved a tiny fraction of a distance. So technically, we're not actually seeing it where it actually is, but where it was. Now, you might wonder why I've just wasted your time talking about that, but I kind of need to do that to link into my theory about the objects passing each other at the speed of light. So I'll do that now. So first of all, here we've just got our eyeball in space, and we've got a yellow ball that's going to represent the other object. Now, if they're both stationary, the light just travels from the object to the eye at the speed of light, and we're able to see the yellow ball. Now, in Valhalla's example, the object is coming towards us at the speed of light. Now, also, he said that we would be going towards the object at the speed of light. I'm just going to put that to one side for 1 second and just concentrate on the object coming towards us at the speed of light. Now, in terms of would we be able to see it, I think what we would be able to see is any light that had first either reflected from or emanated from the object prior to it accelerating to the speed of light. Now, for this hypothetical, I'm going to have to assume that it wasn't at the speed of light to start with, because if it was already at the speed of light instantaneously, then yeah, I guess we wouldn't have had a chance for the light to reach us until the object reaches us at the same time. So for the sake of this, for the sake of argument, I'm going to say it took a little bit of time to accelerate up to the speed of light. I think that's reasonable. So once it's at the speed of light, any new light reflecting from it would be traveling at the same speed as it, so it wouldn't arrive to our eye any quicker than the object itself. However, any light that reflected from the object before it got to the speed of light would precede it, would be in front of it. And so if this was coming straight at us, if we were stationary and this object was coming straight at us, we would be able to see its arrival briefly before it smacked us clean in the face and went straight through our head. Let's face it, at the speed of light, we ain't surviving that. But this is just a hypothetical. Like I say, Valhalla's question was two objects traveling at the speed of light but in opposite directions. They pass each other. What would be visible? What would not be visible? Meow. So from that bit so far, I'm going to assume that the object would be briefly visible on its approach if we go by the assumption that it wasn't at the speed of light to start with. It had to accelerate to the speed of light. And it would be visible by means of light reflecting from it, from the nearest star, or let's just say, for this example, we'll say the sun. We'll say it's close to our solar system. The sun is the nearest large light source, and the light is reflecting from the object. Obviously, if the object created its own light, it would also have light coming from that, like if it was a torch, an LED, that kind of thing. But I'm not going to muddy the waters of this hypothetical too much. I'm just going to keep it simple and say it's just in the solar system, and we can see it from the reflection of the light from the sun in the same way that we see the moon. So that's my first answer about it would be visible on its approach, although very briefly, depending on how long it took to get up to the speed of light, we would at least see the object coming towards us before it goes whooshing past us, even if for a brief period of time. Okay, so next part of this, I'm going to concentrate on when the objects are passing once they're next to each other. So going towards each other at the speed of light, and we're going to stop time here at the point where they're passing each other. Because the objects are very close to each other, or in this instance, the eye and the yellow ball, they would be visible to each other for that split second. If we've paused time, they're right close to each other. I mean, this is hard to conceptualize because we're talking about two objects going past each other at the speed of light, but hypothetically, they would be both visible to each other, for this brief period of time as they're close next to each other, slightly past. That light coming in all directions from them would be visible to each other. Although it's hard to comprehend what it would look like, I do believe that the light reflecting from each object would be visible to each other, even if very briefly. But the next part of this scenario is where things get really interesting, because once the objects have passed each other, the difference in the speed between them is twice the speed of light, because they're going in opposite directions. So no new light bouncing from the yellow ball would be visible to the eye, because it can't catch up. However, as it passed the eye, this yellow ball would have been reflecting light in all directions for this hypothetical, which means that some light will be traveling in the same direction as the eye at the speed of light, and the eye is moving at the speed of light. So some light that was bouncing off the back of this ball is traveling along right next to the eye at the same speed. Now, this is a bit where it's really interesting, because what does this look like? I have literally no idea. Would it be some kind of ghost ball image? A kind of a snapshot in time floating next to the eye because that light is traveling at the same speed. So will it constantly be there next to it, visible? I just don't know. It's fascinating. So this is a bit where I'd love to get Valhalla and MightyMeat's take on this, because once these things have passed each other, meow, there's going to be some light traveling in the same direction as each object from the other object that's been reflected off of it. So what would that look like? Would they see a kind of almost holographic type image moving with them? Would it just be a jumble of some of the colors of light? Now, what I don't know if this is something that would always be a mystery, or whether this is something that physicists can try and work out, with their formulas or with supercomputers, whether they can recreate this in a virtual world or in a virtual space. MightyMeat, that might be one for you or your friend that is the physics guy. I would love to know the answer to that one, because I can think of the scenario in my head, but I can't model it out or map it. I'm not a physics dude. I don't know. And I'm wondering if anybody in the physics world has ever tackled this or written a paper on this. That'd be really interesting. I'd love to know whether this has actually been looked at as one of the theoretical mysteries to crack. So, MightyMeat, you'll have to tell me, is what I'm saying actually making sense? Am I getting the physics of this right? Or am I just talking a load of bollards? So that's my little response to Valhalla and MightyMeat. Over to you guys. Let me know what you think. Catch you later. Bye. Meow.